Okay, in part 10, we're going to look at how we can constrain the address space. So we can introduce constraints on the resolution process to introduce boundary conditions to the address space to prevent unwanted stuff being resolved and to keep a separation of things that we want to keep protected and private away from other stuff. So what we have here is an address space, and this is going to show the use of the limiter. And this address space contains 3 endpoints. It's got, we'll start at the bottom, it's got an import of layer 1. It's got our old favorite, the active column 1 accessor 1, and up at the top here it's got an endpoint declaration, and this is different to what we've seen before with an accessor declaration. This is saying instantiate an endpoint here, but instead of using a class as we've seen before, use something called a prototype. And a prototype is actually an identifier to an accessor. So we can instantiate effectively like a class an endpoint an endpoint which has a prototype declaration. So in this case, layer 1 is providing an endpoint that's called the limiter endpoint, and we're instantiating an instance of the limiter just here in this point of our address space. And just like any other endpoint, the limiter can have a grammar. So in this case, I've given it the grammar of active column 1. So this limiter has the same grammar as our endpoint just here. Now, what does a limiter do? Well, the best way to show that is to try it. What happens if I resolve active column 1? Well, nothing happens. It doesn't resolve. And yet we saw that the space contains an endpoint that's called active column 1. In fact, it contains 2 endpoints called active column 1. As we know, the resolution order starts at the top of a space and tries each endpoint in turn. So what happened in our resolution trace? Well, we tried to resolve active column 1 in the part 10 endpoint. We matched on the limiter endpoint, and the limiter endpoint says, yep, that request matches my grammar. But a limiter endpoint is kind of like antimatter to requests or to resolution. If you match on a limiter endpoint, then the limiter endpoint terminates resolution. It's like penicillin to a bacterium. So the limiter endpoint explicitly terminates the resolution, and so the resolution in our address space appears to not be there at all. If I change the grammar of the limiter to active 2 and now try and re-request or re-resolve active 1, notice we can now resolve, because the limiter, even though we tried to resolve against the limiter, its grammar's now changed, and we get past the limiter and are able to resolve on accessor 1. I can do much more general patterns, so I can say active group regex type anything. So that limiter is super penicillin, if you like. That's going to limit and prevent any request to an active accessor in this address space. So for example, if I want to separate res colon web application addresses from active colon service implementations, I could implement a limiter like this, and this would ensure that only the res space res resources were resolvable in this address space. So let's try active column 1 resolved in this address space. See, it's terminated. If I try active column 2, that's also terminated because they both match on that grammar. So the limiter is a powerful way of either providing global, so that's a match on anything that ever reaches this point in the resolution space. Now with that grammar will be terminated. So that'll basically mean this is a dead end space. So what I can do is I can use the limiter as a very selective, either a very selective way of constraining the resolution capabilities. So I can sandbox an address space with carefully defined limiters to just selectively allow only certain sets of resources to be resolved, or I can use it as a sledgehammer and use it to terminate all resolution if it reaches that point.